A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey everyone, welcome back to another episode of My Weird Prompts. We are coming to you as always from our home in Jerusalem. I am Corn Poppleberry, and sitting across from me is my brother, the man who probably knows more about ARM architecture than is strictly healthy for a social life.
Herman Poppleberry, present and accounted for, and I will have you know, Corn, that understanding instruction sets is a perfectly valid hobby. It is certainly more productive than whatever it is you do when you are staring at the ceiling for 3 hours.
I am a sloth, Herman. Staring at the ceiling is my version of high-intensity interval training, but today we are actually diving into something that has been bothering both of us lately. Usually, our housemate Daniel sends us a specific audio prompt to chew on, but today we decided to hijack the show and pick a topic ourselves. It is something that came up while we were trying to set up a simple information dashboard in the kitchen.
Oh, do not get me started on that kitchen setup. It was supposed to be simple. We have this beautiful high-end smart television, a 2026 model that cost a small fortune, and all we wanted was to display a few basic RSS feeds, a weather widget, and maybe a news ticker. It is basically a web page with some text and a couple of small images. And yet, the interface was stuttering like a budget smartphone from 2012.
It is a total paradox, right? We are talking about a screen that can render 40 million pixels per second in beautiful high dynamic range, but it chokes when you ask it to scroll through a list of text. This led us to a bigger question that we know a lot of you have wondered about. Why do expensive smart TVs have such abysmal performance for basic user interface tasks? Why can a $35 Raspberry Pi handle a dashboard effortlessly, while a $2,000 television struggles to breathe?
It is the great smart TV tax, Corn, and it is not a tax you pay in money, though you do that too. It is a tax you pay in silicon and software optimization. Most people see a thin, flashy television and assume there is a powerhouse of a computer inside it. In reality, the bill of materials for these devices tells a very different story. If you look at the actual cost of the components, the system on a chip, or SoC, often represents less than 2% of the total cost of the television. They spend all the money on the glass, the backlighting, and the marketing, and then they find the cheapest possible brain to run the whole thing.
That is wild. 2%? So on a $2,000 TV, they are spending maybe $40 on the processor? That is literally the price of a Raspberry Pi.
But the Raspberry Pi is designed with a general-purpose mindset. It is meant to be a computer. A TV manufacturer has what I call the appliance mindset. They see the TV as a video delivery vehicle first, second, and third. Everything else is an afterthought.
Let us start there then. When we talk about the brains of a television, we are talking about that system on a chip. How does the processor in a flagship Samsung or LG compare to something like a Raspberry Pi or even a modern smartphone?
It is not even a fair fight. If you look at the silicon inside most high-end TVs, you will find chips from manufacturers like MediaTek, Novatek, or Realtek. These are specialized chips, but they are specialized for one thing and one thing only, and that is video processing. The actual general-purpose CPU cores, the part of the chip that handles the operating system and the apps, are usually years behind the curve. Even in 2026, we are often talking about quad-core ARM Cortex-A55 or maybe A73 designs. These are architectures that were cutting edge in the smartphone world maybe 6 or 7 years ago.
So even in a brand new model television, the actual processing cores might be ancient?
Precisely. And the reason is simple economics. The panel is the most expensive part of the TV. The manufacturers are fighting for every penny in the profit margin. If they can save $5 by using a slightly slower SoC, they will do it. They justify this by saying that the TV is a video appliance, not a computer. They invest all their silicon real estate into what we call ASICs, or application. Specific integrated circuits. These are little hardware blocks dedicated to decoding H.2.5 video or AV1 content or upscaling low-resolution video using machine learning models. Those parts are fast. They're incredibly efficient. But the moment you drop out of a video stream and back into the UI, you are relying on those weak, general-purpose CPU cores to do the heavy lifting.
That explains why the video looks great, but the menu feels like it is moving through molasses. It is like having a car with a massive engine that can only go in a straight line, but the steering wheel is made of wet cardboard.
That is a perfect analogy. The video decoder is the engine, and the CPU is the steering. When you are watching a movie, the engine is doing all the work. But when you want to change the volume or browse Netflix, you are fighting with that cardboard steering wheel. And it gets worse when you talk about memory bandwidth. In a computer or a Raspberry Pi, the memory is shared, but the system is tuned to give the CPU quick access to data. In a smart TV, the memory bandwidth is almost entirely prioritized for the frame buffer of the video engine. The UI is fighting for the scraps.
Let us talk about the dashboard problem specifically. If I'm just loading a web page with some RSS feeds, why is that so hard? A Raspberry Pi 5 has a similar ARM architecture, but it feels snappy. What is the difference in how they handle that specific task?
This goes back to a concept we touched on in episode 644 when we talked about single-board computers. A Raspberry Pi is a general-purpose computer. Its memory architecture and its operating system are designed to handle many different types of tasks at once. In a smart TV, when you try to render a dashboard, you are usually running it inside a built-in web browser engine, something like a very stripped-down version of Chromium or WebKit.
And those browser engines are notoriously hungry for resources.
They are massive. To render a modern web page with JavaScript and CSS animations, you need a lot of RAM and you need fast single-core CPU performance. Most smart TVs have maybe 2 or 3 gigabytes of RAM, and a huge chunk of that is reserved for the system OS and the video buffer. When the browser tries to manipulate the DOM, which is the internal structure of the web page, it quickly runs out of headroom. The Raspberry Pi, on the other hand, might have 8 gigabytes of fast LPDDR4X memory. It is not fighting itself for resources. It can dedicate its entire being to rendering that dashboard.
It seems like there is also a massive software problem here. We live in a world where everything is a locked-down ecosystem. Samsung has Tizen, LG has WebOS. These are not just operating systems, they are advertising platforms.
You hit the nail on the head. This is the part that really frustrates me. If you take a clean version of Linux and put it on a weak processor, it can still feel okay if it is optimized. But Tizen and WebOS are not clean. They are running dozens of background processes that the user never sees. There is telemetry that tracks what you are watching so they can sell that data to advertisers. This is often called ACR or automatic content recognition. It is literally taking screenshots of your screen several times a second, hashing them and sending them to a server to identify what you are viewing.
Wait, so when I am trying to scroll through my newsfeed, the processor is also busy taking secret screenshots and reporting my viewing habits back to a server?
Precisely. There was a study a while back that showed some smart TVs send data packets several times a second even when you are just sitting on the home screen. Every one of those background tasks takes up CPU cycles. Every one of them creates what we call an interrupt, which pauses the UI rendering for a split second to handle the network traffic. When you add all those split seconds up, you get a stuttery, laggy mess. It is basically bloatware at the firmware level. They are prioritizing the ad insertion engines and the data collection over the actual user experience.
It is funny because most people think that a higher resolution screen requires a faster processor. They see an 8K TV and think it must be a beast. But as you said, the silicon for the pixels is separate from the silicon for the logic.
Right. Pushing pixels to a panel is a solved problem in hardware. You do not need a fast CPU to display 8K video, you need a fast decoder and a high bandwidth display controller. But to run an app, to handle user input, to manage a file system, you need a computer. And manufacturers are giving us the bare minimum computer they can get away with. They know that most reviewers only look at the picture quality, not the latency of the settings menu.
I remember we talked about this a bit in episode 762, when we discussed the decoupled brain fix. The idea was that you should never rely on the smarts built into your devices because they have a much shorter shelf life than the hardware itself.
That is the life cycle mismatch. Think about it. How often do you replace your television? Maybe every 7 to 10 years? But how often do you replace your phone? Every 2 or 3 years? Software standards move at the speed of the phone market. In 3 years, the web standards for your news dashboard will have evolved. The advertisements on the home screen will be more complex. The telemetry will be more invasive. Your 7-year-old panel is still beautiful, but the 2-year-old processor inside it was already obsolete the day you bought it. It is a recipe for planned obsolescence, even if it is not intentional. The performance degradation is statistically significant after just 18 to 24 months because the OS updates keep adding more background overhead while the hardware stays the same.
So, if someone is listening to this and they are frustrated with their smart TV performance, what is the actual move? Is there any TV out there that actually has good internal hardware, or are they all just different versions of the same problem?
There are some differences. For example, TVs that run Android TV or Google TV tend to use slightly more powerful SoCs because Google has higher minimum hardware requirements for its partners. Sony, for instance, often uses the MediaTek Pentonic series, which is a bit more robust than the bottom-tier chips you might find in a budget brand, but even then, it is still not going to beat a dedicated external box. Even the best TV SoC is usually only allocating about 15% of its total compute power to the UI layer. The rest is locked away for video processing.
And that brings us to the decoupled strategy. If the internal brain is the bottleneck, we just bypass it entirely.
That is the only way to maintain your sanity. You treat the TV as a dumb monitor. You disable the internet connection on the TV itself so it cannot run its background telemetry and ad engines. Then you plug in something that was actually designed to be a computer. An Apple TV 4K, an NVIDIA Shield, or if you want to be like us, a Raspberry Pi or a small form factor PC like a Nuke.
I want to talk about the Raspberry Pi option specifically because that is what we ended up doing in the kitchen. For someone who is not a total nerd like you, Herman, how hard is it to set that up as a dedicated dashboard?
It is actually easier than it used to be. We talked about this in episode 649 regarding DIY information radiators. You can set up a Pi in what is called kiosk mode. You basically install a lightweight version of Linux, tell it to open a browser on startup, and point that browser to your dashboard URL. There are no ads, no telemetry, no background updates trying to sell you a subscription to a streaming service you do not want. It is just the raw power of the chip dedicated to your task.
And the performance difference is night and day. When we switched the kitchen dashboard from the internal Tizen browser to the Raspberry Pi 5, it was like someone had finally taken the parking brake off.
It is transformative. You get 60 frames per second smooth scrolling. You get instant response times. And the best part is, when that Raspberry Pi becomes too slow in 4 years, you spend $50 or $60 to upgrade the brain, but you keep your $2,000 display. You have decoupled the display technology from the compute technology. This is exactly what professional AV integrators do. If you go into a high-end sports bar or a corporate boardroom, they are almost never using the smart features of the TV. They have a dedicated media player hidden behind the screen.
But what about the convenience factor? One of the reasons people love smart TVs is the single remote. If I plug in a Pi or an Apple TV, am I back to having 4 remotes on my coffee table like it is 1995?
That is where HDMI CEC comes in. That stands for Consumer Electronics Control. It is a protocol that allows devices to talk to each other over the HDMI cable. Most people do not realize that their TV remote can actually control their external boxes. If you set it up correctly, when you turn on your Apple TV, it turns on the television and switches to the right input. You can use the directional arrows on your Samsung remote to navigate the menus on your external device. It feels integrated, but you are using the superior processing power of the external box.
It is funny how we have moved from the era of the VCR, where everything was separate, to the integrated smart TV, and now we are moving back to separate components because the integrated software is so bad. It is a full circle.
It is a cycle of specialization. We tried to make the TV do everything, but we forgot that the TV manufacturers are not software companies. They are hardware companies and data brokers. Their incentive is not to give you a fast UI, Their incentive is to make the TV as cheap as possible to manufacture and as profitable as possible to track. In fact, some manufacturers have admitted that they sell the hardware at a near loss because they make so much money from the data they collect through the OS.
I think there is also a point here about the lockdown nature of these operating systems. If I have a Raspberry Pi and it is running slow, I can go into the terminal, look at the running processes, and kill the ones I do not need. On Tizen, you are a guest in your own living room. You cannot uninstall the preloaded apps. You cannot stop the telemetry without jumping through insane hoops. You are stuck with whatever version of the OS the manufacturer decides to push to you, which usually includes more features that slow down the hardware.
It is a lack of agency. And for us here in Jerusalem, we often have different needs than someone in the States. Maybe we want specific local news feeds or Hebrew language support that is not prioritized by a global firmware update. When you have your own box, you have total control over the localization and the content. You are not waiting for a corporate giant to decide that your region is worth an update.
So, let us look at the second-order effects of this. If everyone starts using external boxes and treating TVs as dumb monitors, what does that do to the TV industry? Do you think we will ever see a return to high-quality dumb displays?
I would love to say yes, but the data says otherwise. As I mentioned, manufacturers actually make more money from the post-purchase data and advertising than they do from the initial sale of the hardware in many cases. If they sold a dumb monitor, they would have to charge more for it because they are losing that recurring revenue stream. That is why professional-grade monitors, which have no smart features, are often more expensive than consumer TVs with the same panel quality. You are paying a premium for the privilege of not being tracked and having a fast interface.
That is a depressing realization. You're paying with your data to get a cheaper TV, but that data collection is what makes the TV feel like garbage to use. It is a self-defeating cycle for the consumer.
It is a race to the bottom, but the savvy consumer, the people listening to the show, they know how to game the system. You buy the TV with the best panel for the best price, you never give it your Wi-Fi password, and you plug in your own brain. You get the subsidized hardware price without the software headache. It is the ultimate tech life hack for 2026.
I like that. The subsidized hardware price without the software headache. That should be the motto for modern tech living. Now, Herman, for someone who is really into the weeds on this, are there any open source TV projects? I am thinking about something like a TV version of Graphene OS, or a way to flash a clean version of Linux onto a Samsung TV.
People have tried. There is a project called SammyGO for older Samsung TVs that allowed for some custom firmware, but it is incredibly difficult on modern sets. Modern TVs use secure boot and encrypted firmware. The manufacturers have locked the doors and welded them shut. They do not want you replacing their ad-ridden OS with something clean. It is a cat and mouse game, and right now, the manufacturers are winning on the internal hardware front. That is why the external box is not just a good idea. It is currently the only viable path for a high-performance experience.
It feels like we are in a transition period. We have these incredible displays. Micro LED is becoming more common. OLED is getting brighter and cheaper every year, but the brains are stuck in the past. I wonder if we will eventually see modular TVs where the SoC is a card you can slide in and out of the back of the panel.
Samsung actually tried that years ago with their Evolution kit. It was a great idea. You could buy a new module every 2 years to upgrade the processor, but they killed it. Why? Because it is more profitable to sell you a whole new 75-inch television than a $200 upgrade module. The industry is not incentivized to be modular. It is incentivized to be disposable. They want you to feel that lag in 3 years and think, maybe it is time for a new TV, rather than thinking, maybe I should just buy a new $50 stick.
Which is why we have to take matters into our own hands. Let us pivot to some practical takeaways for the listeners. If you are sitting there looking at your laggy dashboard or your stuttering Netflix menu, what are the steps to fix this?
Step 1, as I said, is to cut the cord on the TV's internal internet. If it has an Ethernet cable, unplug it. If it is on Wi-Fi, go into the settings and forget the network. This immediately stops the background telemetry and ad checking cycles, which can actually give the UI a little bit of breathing room. It is like clearing the throat of the processor.
Step 2. Pick your brain. If you want the easiest experience, get an Apple TV 4K or an Nvidia Shield. They have the fastest SoCs in the consumer streaming space. They are significantly more powerful than the chips inside even the most expensive TVs. If you want the ultimate dashboard experience, get a Raspberry Pi 5.
And step 3, learn to love HDMI CEC. Go into your TV settings, look for something called OmniNet Plus on Samsung or Simplink on LG or Bravia Sync on Sony. Enable it. Do the same on your external box. Now your remote works for everything, and you have bypassed the manufacturer's bloatware. You get the best of both worlds, the convenience of one remote and the power of a real computer.
It is also worth mentioning that for those of you who are really adventurous, using a small form factor PC, like an Intel NUC or one of the new AMD-based mini PCs, is the absolute gold standard. You are getting a full desktop class processor. It makes a Raspberry Pi look slow. If you want a dashboard that can handle complex data visualizations or 30 different news feeds with live video, that is the way to go.
We have a new C in the office that runs a massive monitoring wall, and it does not even spin its fans up. It is overkill, but it is beautiful. And it reminds you of what the hardware is actually capable of when it is not being strangled by bad software. We are talking about the difference between a device that struggles to render a JPEG and one that can handle real-time data processing without a hiccup.
I think the broader lesson here is that as consumers, we need to stop valuing integrated features and start valuing modularity and open standards. The flashy smart TV box is a lie. It is a marketing gimmick to hide a cheap computer. We should be looking at the panel as a canvas, and the external box as the artist.
It is the difference between an appliance and a tool. An appliance is something you use until it breaks or becomes obsolete, and then you throw it away. A tool is something you maintain, upgrade, and control. By adding an external brain, you are turning your TV from a disposable appliance back into a high-quality tool. You are taking back control of your living room.
That is a great way to put it. Now, we should probably address the elephant in the room. Are there any downsides to this? Is there anything you lose by not using the internal apps?
There are a few minor things. Sometimes, the internal apps are better optimized for specific proprietary HDR formats like Dolby Vision or HDR10+, especially on budget TVs where the external box might not communicate the metadata perfectly. But on high-end panels in 2026, this is rarely an issue anymore. Most modern external boxes support every format under the sun. The only other thing is that you might lose access to some very niche manufacturer-specific features, like Samsung's Art Mode, or specific ambient display modes, though you can usually replicate those with your own images on an external box anyway.
So the trade-off is basically 5% less integration for a 500% increase in performance and privacy.
I will take those odds every day of the week. And honestly, once you see how fast a Raspberry Pi 5 can render a complex dashboard, you will never want to go back to the internal TV browser. It is like going from a bicycle to a jet engine.
Me too. And it is not just about the speed, it is about the principle. I do not want my television to be a spy in my living room. I want it to be a window to the world that I control. I want to know that when I click a button, the processor is working for me, not for an advertiser in another time zone.
Well said, Korn. It is about reclaiming the hardware. We spend a lot of money on these screens. We should be the ones deciding what runs on them. And if that means we have to plug in a little green circuit board to make it work right, then that is what we will do.
Well, I think we have thoroughly deconstructed the smart TV myth today. It was fun to take the reins and dive into something we are both so passionate about. If you have been struggling with a laggy interface, hopefully, this gives you the confidence to go out and get a separate brain for your display.
And if you do set up a cool dashboard using a Raspberry Pi or a NUC, let us know. We love hearing about how people are customizing their setups. You can reach out through the contact form at myweirdprompts.com. We are always looking for new ways to push this hardware to its limits.
Speaking of the website, we have a massive archive there. If you enjoyed this technical deep dive, you should definitely check out episode 649 on DIY information radiators. We go into much more detail on the software side of building those dashboards, including how to set up Linux in kiosk mode. Or, if you're interested in the hardware side, episode 730 covers the difference between ARM and x86 architectures, which is at the heart of why some of these chips are faster than others.
And hey, if you've been listening to us for a while and you are finding value in these discussions, please consider leaving us a review on your favorite podcast app or on Spotify. It really does help the show reach more people who are tired of their smart TVs being dumb. We want to build a community of people who take their tech seriously.
It genuinely helps. We are a small operation here in Jerusalem, and every rating makes a difference. It tells the algorithms that people actually care about why their menus are lagging.
One last thing before we go. We should mention that the future might not be entirely bleak. There are some movements in the industry toward more open standards even if they are slow. The Matter protocol for smart homes is a start. Maybe one day we will see a Matter-like standard for TV operating systems that allows for more interoperability and less bloat. Imagine a world where you could choose your OS like you choose your wallpaper.
We can dream, Herman. But until then, I'm sticking with my Raspberry Pi. It has never let me down, and it does not try to sell me laundry detergent while I am checking the weather.
Wise choice, brother. Wise choice. Stick to the hardware you can trust.
All right. That is going to do it for this episode of My Weird Prompts. Thanks to our housemate Daniel for letting us hijack his segment today. We will be back next time with whatever weird idea he throws our way. Hopefully it involves fewer laggy menus and more interesting puzzles.
Thanks for listening, everyone. Stay curious.
See you next time. This has been My Weird Prompts, available on Spotify and at myweirdprompts.com.
Stay curious and keep your displays dumb but your brains smart.
Goodbye.
Bye.
You know, Herman, I was thinking about that sloth comment earlier. If I am a sloth, does that make you the donkey because you are so stubborn about your Linux builds?
I prefer the term steadfast, corn. And donkeys are very intelligent animals with excellent memories. They do not forget when someone insults their hobbies.
That explains why you still remember the command line arguments for a kernel update from 2004. You have the memory of a very nerdy elephant.
They were useful then, and they are useful now. You never know when you might need to compile a driver for a legacy serial port.
Sure they are. Let us go get some hummus. I think my brain needs some fuel after all this talk of silicon and memory bandwidth.
Now that is an idea I can get behind. Hummus is the ultimate general-purpose fuel.
Last one to the shop pays.
Hey, wait, you started running before I finished my sentence. That is a false start.
Advantage, sloth. I've been conserving my energy all day for this.
That is not how sloths work. They are supposed to be slow.
It is how this one works. See ya.
I am coming for you, Poppleberry. I will use my superior cardiovascular efficiency to overtake you.
You have to catch me first. I'm already at the corner.
I will catch you at the finish line. My hiking boots are built for this.
We will see about that.
Oh, it is on.
Thanks again for listening, everyone. Seriously, go check out the website. We have so much more content there, including photos of the kitchen dashboard that started this whole rant.
And do not forget the review. We really appreciate it.
All right, let us go. I can already taste the tahini.
I am right behind you.
No, you are not. You are still fixing your shoelaces. I can hear the Velcro from here.
These are high-performance hiking boots. They take time to secure properly for a sprint. It is all about the stability.
Excuses, Herman, excuses. You are just stalling because you know you are going to lose.
Just you wait until I get my momentum going. I am like a freight train.
I will be halfway through my pita by then. I will order you the spicy one as a consolation prize.
We shall see.
We shall indeed. Bye, everyone.
Bye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.